The next presentation will also be a very theoretical presentation about retrieval-augmented generation and applications in archives. The presenter is Domonkos Czifra, is also researcher at the Rényi Mathematic Institute.
In the next 15 minutes, I would like to talk about retrieval-augmented generation and applications in archives. So, why RAG systems are very important? Because what Gabor mentioned earlier, it is a huge step towards having this digital archivist. And what made this possible, that we have this vision, is the recent advancement in LLMs. So let me shortly introduce LLMs. So they are artificial intelligence programs that can recognize and generate text among a wide range of tasks. They are pre-trained on a large amount of data, so that's why there is only a few companies who have the infrastructure and this data that they can do the training. The most modern LLMs are based on transformer architecture, so they are an encoder and decoder with the self-retention capabilities. And LLMs are very good in question answering, summarization, language translation, and completing sentences. But using LLMs in question answering has some limitations. So first, they do not have up-to-date informations. So if you want to add some new data, you could retrain the model, but it could take a lot of time and it is very expensive. Large language models can hallucinate, so they can answer questions even if they don't have any information about the underlying data. And it is hard to add domain-specific informations to LLMs. And if pure LLMs answers the questions, it is hardly to explain how this decision mechanism was made, and so it is not easy to explain why we got this answer. So to cope with these problems, RAG is one of these advanced technique that is used in question and answering systems and in chatbots. So it combines retrieval and the generation process to enhance the capabilities of LLMs. So it first retrieves the information from a knowledge database, and secondly, it uses this retrieved information to generate a coherent and contextually relevant response. So shortly, RAG empowers the LLMs with accurate, up-to-date informations. So how does it look like? What is the mechanism of RAG? So it has three different parts. First, in a question answering setup. So first, it gets a question, and it is looking for relevant documents in a specific knowledge base. Second, it extends the question with the relevant knowledge. And third, with this knowledge, it can answer the question and generate the output. So why is it possible? So how can we retrieve data from a knowledge database? First, it is based on embedding models. So the idea is that we take an embedding model and we embed our documents into a vector space. And the idea behind that similar documents will be embedded closely to each other, and so similar question to a question, the answer and the relevant document should be very close to each other. So how do we do this retrieval? So we get a question, we embed it with our model, then we get a vector in our vector space, and we look for the closest documents, which is close to this point, and we give back those documents. Yes. So there are some challenges how we make this retrieval. So if we have two large documents, because this embedded vector is in a fixed dimensional space, so we cannot embed infinite information in that, so just a small part of that. So that's why we need to chunk large documents into smaller parts. And doing this is not so trivial. So if we split a document, then maybe the information is also splitted, and one of the chunks gets all of the information, the other less. So that's why we need to do it very carefully. The other one, doing this ranking of the relevant documents is very important. So it is we can improve the performance if we have a better model to re-rank these retrieved documents, and of course the basic quality of the data is very important. So if you have OCR data or the information is hard to find in these documents, then of course this will be a very hard problem. So if you can improve on this data, then your RAG performance will be a lot better. So I would like to talk about re-ranking. So re-ranking is also very important, because if your database is very large, you have a lot of documents, then doing retrieval can be very expensive. So you need to have a fast retrieval algorithm and a fast embedding model. And finding similarities and finding relevant documents should be fast. So we cannot have a very large language model to do this task. So we can do it in two steps. So first we find some relevant documents, and in the second phase we can use a larger model to re-rank these relevant documents to give just a few number of relevant documents to the LLM. There are a lot of commercial solutions for this re-ranking, but open source models are also very good. Okay. Having a RAG on archive documents on Hungarian language is challenging because of two aspects. One, that having a RAG on Hungarian language is hard because these language models are not so good on Hungarian. The second, archive documents are noisy because we get it from OCRization. So that's why we wanted to make comparison with the original setup, that you have a RAG system on English, on clean data, and in our setup. So we created 3 data sets. One from not noisy data set on Hungarian language, we got from Hungarian websites. And a second one, we translated it into English. And the third one, we had some OCR news from the National Archives of Hungary. So it is very interesting if you compare the performance of the Hungarian and the English data sets. We can see a lot of embedding models. I show here the hit rate, so how much times in a synthetic data set you can find the relevant parts for the question. And we can see that, that most of the models were quite good on English. So we have good scores, but on Hungarian, the red ones are very bad. So it is very crucial if you work on a language which was not included in the trained data set of the large language model, to have the good embedded model. The second interesting thing is what can do these models with noisy data, and we can see that they can cope with it, but it is also very crucial to find the best one and what is most robust on this data. Let me introduce shortly our whole pipeline, not just the retrieval part. So we find out that the BGA M3 model is the best in our case. We give back the top 5 relevant documents usually, and we do the generation with Llama 3.1 with a smaller model. And we did this demo on Hungarian news from 1922 from the National Archives. And it is not a big data set, so we want to scale up, but this is just for demonstration and to get the limitation of our framework. We used 3 key technologies to have this pipeline. First, OLAMA, which handles our models. The second, Llama Index, which handles the REC pipeline. And the third one is Open Web UI, which is helpful to have a user interface to this model. We can put some questions to this pipeline. The example here is that what is who are Kemalists? So Kemalist is actually a Turkish political ideology, and we have some information about it in our data set, and our pipeline can find it successfully. I want to make some notes about that the embedding model is very important, and we can do also we can compare not just the retrieval part, but also the whole pipeline, the comparison in the whole pipeline, so we asked the question who was elected to the House of Commons in London and when, and we can see that some of the embedding models can find the relevant parts, the others not, and that's why it gives the answer that it cannot find the information. The other very important thing is how we make the embedding, because some documents have the informations in a very spread way. So the chunking is if we can do the chunking, maybe the retrieval will be very hard. So sometimes it is beneficial to make some metadata from documents and embed this metadata. Sometimes it is useful if we do a summarization or a keyword extraction and we embed it. this, and then the retrieval part will be a lot easier. Okay. So I would like to mention some future works, what we would like to do. So first we would like to scale up our model to work on a large amount of data. The other one, working with knowledge graphs and having hybrid search, which can work much better on a large scale data. And third, we would like to fine-tune our models because we are not doing yet fine-tuning because it is very hard. So if you fine-tune your LLM or embedding model, it can be very difficult. So, but we think that this is a very interesting topic and an important one. So thank you for your attention.
Thank you, Domonkos, for your presentation. We are still on time, and there is time for questions.
Yeah, thank you for the presentation. My question would be if does the answer in such a system include information about if there were good information found in the documents? If it's does it indicate if it has some sure things to say, or if it's from general, or does it even hallucinate sometimes, or does this way solves this problem?
So if we do not find any relevant parts in the documents, then in the prompt you can give the LLM that do not give any answers. So that's easy. The other one, how sure is the LLM in the answer based on the relevant documents? We can use the score of the retrieval part because mostly we use cosine similarity between the embedded question and the documents, and this similarity score can be a sign of how confident you are in your answer.
Further questions?
Thanks for the presentation. Also, I'm working on something similar in Belgium. But one question that I have is, didn't you have any trouble with drifting of the language? I mean, historical language, which I'm working on, is extremely different from today's language. So the embeddings are likely to be kind of different. Did you have to compute some kind of alignment model or anything of the like, so that the query could be embedded in the same space as the document space?
So this is a very interesting question also. We noticed also that the distribution of our text is very different what we have now. So in our future work we would like to fine-tune our embedding models to this different distribution of data. But what I think is very interesting how you can solve that. You would like to put your question on your language and get the answer on historic language. So, thank you.
Questions? Further questions? Excuse me? Oh.
For the future, you mentioned that you also plan to do the hybrid search. So I wonder what type of semantic technologies did you have in mind to integrate, if you already looked into it?
Sorry, can you repeat?
Yes. So in the more complex knowledge representation part, you said that you intend to do the more hybrid search, including keywords, and I wonder what type of semantic technologies did you plan to include, if you already looked into it?
So yet we tried some classical methods like BN25. This is a classical text search method, and we just did experiments with having different type of metadata, and we also did the classical method, and we embedded this metadata, but we are thinking about making search on the metadata and not embedding it. So.
Does this also include creating ontologies and looking in knowledge graphs?
Yes. We think about it, but we did only just name. We extracted mostly named entities, and yeah, sometimes we did summarizations, but not